All right, so for this video, we're going to focus in on 9.7, folder B. I'm going to start off with just showing you guys how to do the Delta Math assignment that's listed in there. So let me go over to that. All right, so once you guys are logged in here, you'll see that the first assignment for graphing in folder B, graphing sine and cosine, is finding the midline from a trigonometric graph. All right, so what you're doing is you're looking at either a sine wave or a cosine wave, and it's just asking for it says the equation of the midline. Okay, so remember, first of all, before we talk about equation, just remember that midline is just where the middle of this graph is. It's basically the middle point between the peak of your graph and the valleys of your graph. And right here for this graph, that's right down the middle on the x-axis. So, but remember, it's asking for the equation, right? Not just for that value of 0, which is right there in the middle. So for the equation of a horizontal line going straight across is y equals. Okay, you put y equals and then that value. All right, so that's pretty much it for that one. So I'll do one more. So here you can see that the middle, or the midline here, is now at positive 2. So now when I go down here to write out my equation, I simply just write y equals 2. All right, so just do y equals for all of those. All right, so now for the next section, next one you're looking for the amplitude of the graph. So it's helpful to write out or draw that midline again. And the distance from the midline to the peak or to the valley is your amplitude. So you can see from the top to the midline is 1, so that's the amplitude we're looking for. And this one's not an equation, we're just looking for that value. So here I put 1. Okay, on this one, you can see the midline is right here at -2, so we go up 1 again. So again, that one's also 1. Oh, sorry, that was the same problem. My bad. All right, so here we go. Here's a new one. All right, so here the midline is at -1. So that means the amplitude going up to the peak is 2 units. So for this one, it'll be 2. Okay, so basically just counting the distance from that middle line there. All right, so the third one here is you are going to fill in the missing values for the equation. All right, so it could be cosine, it could be sine, doesn't really matter. The main thing is you need to figure out how to get from this solid graph to this dashed graph by changing these values. Now, right here, this value, I want you every time to just put a 1. Because what this does is it changes how long it takes for this sine wave to repeat itself. So you remember that it repeats every 360 degrees, or in this case, 2 pi. If I change this to 2, that basically cuts that in half, and then this would like squish down. And I'll show you what that looks like actually. So you'll notice that when I click this, it squishes it. So now it repeats every pi. Whereas if I went 4, it would actually expand. I'm sorry, not 4, but actually a decimal. It would expand it out. All right. So don't mess with that value. Just put a 1, basically. All right. So let's kind of bring this back to the middle here. All right. So now what I want to do is first look for that midline. Okay. What is the midline of that new graph? The midline, it looks like it's right here at +1. Okay. So for that value, basically, I'm going to put vertical shift or midline at 1 there. So I put 1 here. And then for this point, or for this value, this is the amplitude. So look at your graph and say, okay, well, what's the distance from the midline to a peak? And you can see right there, it's 1, 2, 3. Okay, so you count that distance. So for that value, I put 3. You try it, and you'll see that it kind of expands out and should fit right over it. This little button won't show up until you get it correct, okay? So you basically can keep trying as many times as you want. All right, so here's a sine wave. Remember, I'm going to put a 1 in there. All right, and now first of all, I want to shift it up to here. And so we're shifting it up to this midline here of 3. So that means that's your vertical shift, which I'll put 3 here. And the distance I'm noticing from the midline to the top is just 1. So I'm just going to put 1 there. Okay. All right, so let's try that out. So you can shifts it up. There's really no change in amplitude. So that's it for that one. Okay, let's do one more. All right, so now this one looks like we've got a shift down to a midline of -3, so -3. The amplitude is just 1 again. All right, looks good. And okay, this will be our last one. All right, so now it might get kind of difficult to see where the midline is when it's this big. Well, what I do is I look at the 5 up here and I look at the bottom and see what value they're at. And if that's at 5 and that's at -5, that means the middle must be right on the x-axis. Okay, so if it's on the x-axis, for the vertical shift, that means it didn't shift at all. So if there's no shift, just put 0. Okay, and again, put the period as 1 there. And then for the amplitude, again, that's that distance from the midline up to the top of your graph. So that in this case is 5. And there you go. All right, so that's how you do those delta math problems. All right, so now let's take it to the board, and you guys are going to do these examples in your notes or in your notebook. And again, I'm referring back to your guys' packet. So make sure you guys follow along in your 9.7 packet. Or sorry, in the packet number 2 in assignment 9.7. Okay, so I'm referring to these ones here. All right, so on my board, I'm going to use this left column or this left side as the y-axis, and then I'm going to use the x-axis there. So I'm just kind of pushing the y-axis over to the left a little bit, just so we can show those different values across your x-axis. Now, all the way to the end here, that's going to be 360 degrees. The middle then is 180, and then these two marks are every 90, so that's 90 and that's 270. And just remember, your graph might not be in degrees, it might be in radians. So this would be pi over 2, this would be just pi, this would be 3/2 pi, and this would be 2 pi. And then we'll just go by ones here on the y-axis. So that'll be 5 and that'll be -5. All right, so let's start off by graphing sine, because that's what we did last week. And to graph sine, let's refer back to the unit circle, because that's what this is all based on. Okay, so we're going to start off again with sine, y equals sine of theta. And when you start at 0 degrees, which on the graph is right here, when you start at 0 degrees, the y value, which remember for sine, we're looking at the y value on the unit circle, the y value is 0. Okay, so that means over here, I actually start at 0. And then when we go up to 90 degrees, the y value becomes, the y value becomes 1. So when I get to 90 degrees, my y value is 1. Okay, or my value for the graph is 1. Then when I come down to 180, that point is -1, 0. And again, the y value is 0 there. So my next point will be right on the x-axis at 0. And then when I come down to 270, the point is 0, -1. So that means I come down below 270 to -1. And then when I come back up to 360, I go back to 0. And now remember, it's a wave, right? It's this like curvy wave. So I started on the x-axis, I go up to 1, I come back through 180, come back down through 270, and then come back up to the x-axis there. So that's just sine. Now for cosine, notice how, remember, cosine is the x values, and the x value you start with is 1. So when I come over here, I'm not going to start right on the midline. I'm going to actually start 1 above the midline for cosine. And then when I get to 90 degrees, the x value is 0. So here I come to 0. And then at 180, it's now -1. So here I go below the line. 270, the x value is 0. So for cosine, we go back to the midline there at 270. And then when we come back to 360, we're back to 1 above the line. Okay, so now I start off kind of at a hill and a curve. I come through 90, come down to 180, come back up through 270, and then rise back up to 360. Okay, and you can see that they're very similar. It's just that it's kind of moved over. So if I were to take this cosine graph, or actually let's say I take the sine graph and shift it over, it would basically match up perfectly with the cosine. It's like everything is shifted over 90 degrees. Okay, so now let's say I give you a graph that looks like this. Let's say it's y equals 3 sine of theta minus 2. Well, first thing I want to know, all right, is what's the vertical shift? Well, the vertical shift here is minus 2, so I bring it down 2. And the amplitude is 3. And when you guys do this in the, and actually, sorry, let's do the cosine. Let's not do the sine. All right, when you work on this in 9.7, that's pretty much what you're given, is you need to write down the amplitude, the vertical shift, and then you're going to graph all that. Okay, so first let's start with the vertical shift. It's -2, so at -2, I'm going to draw a dashed line. This is my new midline. The midline's no longer right here on the x-axis, all right? And so I'm going to actually get rid of the sine graph because we're really just focusing on cosine right now. So let me fix that up a little bit. All right, and I'm going to use that as reference so that I know where I need to graph this cosine graph, okay? All right, so again, remember that when I graph cosine, I started 1 above the midline? Well, I do the same thing here. It's just been shifted down. And now remember the amplitude is 3, so it's not 1 above that midline, it's 3 units above the midline. So from the midline, I count 1, 2, 3. That's my first point, okay? And now for the, and actually, let's actually change this to a 4. Let's go 4, just so you guys don't think that it's starting the same spot every time, okay? So then if it's 4, I would go up to 1, 2, 3, 4. I count 3 units above the midline, right? So 3 units above the midline. Then when I get back to when I go to 90 degrees, remember that here I went through the midline. I do the same thing here, except I come through the midline at this point, all right, at 90 degrees and -2. When I come to 180, it's below the line. So here I start at the midline and I count 4 units below. So I go 1, 2, 3, 4. All right, then at 270, we come back to the midline. And then at 360, we're going to now go above. So I count 1, 2, 3, 4 units above. Now, again, I start off at a peak. I come down, curve back under and up through 270, and come back and kind of start to level out there. Your graphs aren't going to be perfect every time, but you do your best on that, okay? All right, so what you guys are going to graph, I want you guys to graph y equals 3 times cosine of theta plus 2. So that's what you're going to graph, and then in your notes, okay? So remember, and write down your vertical shift and your amplitude too. All right. All right, so now I'm going to do another example. One more. Okay, again, keeping that first graph as reference over here. This first one, which is just kind of the cosine of theta. All right, 90 degrees here, 180 here, 270 there. All right, so now let's do, let's say let me use my other color here. Y equals 3 plus, we'll say 5 cosine of theta, okay? Now, notice how that number's in the front, right? Instead of in the back. I'm still adding 3, but instead of it being written behind, it's now written in the front. It's literally the same thing. So the vertical shift, in this case, is 3, or plus 3, and then the amplitude is 5. So first I'm going to graph my vertical shift. So I go up to 3. Make a dashed line there. And then remember that cosine starts above the line, right? So I'm going to start 5 units above. So I count 1, 2, 3, 4, 5. Then I come back down to the midline, right, at 90. Then I go below the midline at 180. So I count 5 units below that. 1, 2, 3, 4, 5. And then at 270, I come back to the midline. And then at 360, I go 5 units above. 1, 2, 3, 4, 5. Sorry, right there. All right, so it kind of little peak, the curves, comes down, bottoms out here, comes back up through 270, and then starts over at 360 again. Okay? All right, so the one that you guys are going to graph is going to be -2 plus 4 times cosine of theta. Now notice that the number that I'm adding is negative, right? So that should be your vertical shift. And there's your amplitude. So go ahead and graph that. Okay. All right, last thing I'm going to go over is what is on the back. And it's kind of a review of finding the equation from a graph. So we'll go over a problem like that back here. Okay, so first I will show you an example. I'm going to show you using this kind of little mini graph here. On my graph, what I'm going to do is we're going to go, let's say we're going to go up through here and then come back through here. And then we're going to bounce right there off of the x-axis and go back up. Okay? All right, so just write in some tick marks here so you guys can see where all that lines up. Now, what you have to do is you're writing an equation, right? You've got a polynomial here that has some x-intercepts and a y-intercept. So the first thing I need to know is the roots. What roots do I have? Or what are the x-intercepts? And I got roots at -2 and at 3. And you guys notice it bounces, right? It bounces at 3. So remember, that's a double root. So I'm going to write that a little bit differently when I first write out the equation. Now I want another point. In this case, they give us a y-intercept on the graph, so I'll use that. Because that's usually the easiest to plug in. And that's at 2. So I write 0, 2 for the y-intercept. Now we can start setting up our equation with y equals. And remember, we're looking for an accurate equation, so we want to look for that a value. And then we'll write out those factors. All right, so let's set that up. So we got y equals a times, remember, if it's -2 for the root, I put x plus 2. And it's plus 3, so I put x minus 3. But because it's a double root and it bounces at that point, oh, I'm sorry, that's actually +2, not 3. Just realized that. So it bounces at 2, +2, so I'm going to put squared. All right, so that square accounts for the bounce. Now what I'm going to do is we got to solve and look for that a value. So I'm going to plug in that y-intercept or whatever point I have. And if you guys notice in the packet, sometimes in some of these problems, it gives you a point instead of an actual y-intercept. So when you guys go back and search through here, I know there was some, oh yeah, actually it was in the week 10 review. Here on the back page, this is the week review, and here they give you 2 x-intercepts plus a point, not a y-intercept. Okay, so sometimes it's not always a y-intercept, but if you got one, it's the easiest thing to plug in. So first, I'm going to plug in the y value, which is 2, and then the x value, which is 0. Okay, so let's simplify and solve here. So 0 plus 2 is 2. -2 plus 0 is -2. And then don't forget we have to square that first. So we got -2 squared, which is 4. And now 2 times 4 is 8. So 8a. And then divide by 8. And that simplifies or reduces down to 1/4. All right, so now when I write out my equation, I'm going to write in the a value, plug that in, and then just rewrite this equation basically with the a value in there. All right, and I'm going to leave it in factored form just like this. I'm not going to like multiply it all out and combine like terms. I just want it in factored form. So that's what you guys are going to do. So here's your graph. Let me write it out for you. All right, so I'm going to use this little mini graph down here. So get a new pen here. All right, and your graph is going to go up through 3, come back down through here, and it's going to bounce right there and go back up. Okay? So with that graph, I want you guys to come up with the equation. Okay? All right, let me move this down here so you guys can see it. Okay? And that's it.